হ্যালো ফ্রেন্ডস, আমি দেবাশিস মাঝি পাথফাইন্ডারে বেশ কিছু বছর ধরে কেমিস্ট্রি পড়াই 11-12 বাচ্চাদের। নিট, জেই মেন, আইআইটি এবং ওয়েস্ট বেঙ্গল জয়েন্টের জন্য যারা প্রস্তুতি নেয় তাদেরকে পড়াই, কেমিস্ট্রি পড়াই। তো আজকে আমাদের এই ছোট্ট একটা ভিডিও সেশন করার একটাই কারণ, আগামী রবিবার 30 এপ্রিল ওয়েস্ট বেঙ্গল জয়েন্ট এন্ট্রান্স এক্সামিনেশন ইঞ্জিনিয়ারিং হতে চলেছে। সো আমাদের কাছে আর মাত্র 2 দিন বেঁচে আছে, 2-3 দিন। তো এই লাস্ট 2-3 ডেজে আমি যদি একজন ওয়েস্ট বেঙ্গল জয়েন্ট এন্ট্রান্স ইঞ্জিনিয়ারিং পরীক্ষার্থী হই, আমার অ্যাপ্রোচ বা আমি লাস্ট 2 দিনে কী দেখে যাব, কি পড়ব কেমিস্ট্রিতে, সেই ব্যাপারেই কিছু কথা এখানে আমি বলবো। তো প্রথম কথা আমি বলি, ওয়েস্ট বেঙ্গল জয়েন্ট এন্ট্রান্সের যে সিলেবাসটা আছে, একটা রিটেন সিলেবাস আছে আমাদের কাছে প্রেসক্রাইব। আমরা সাধারণত অল ইন্ডিয়া +2 লেভেল এন্ট্রান্স এক্সামিনেশন নিট এবং জেই মেনের জন্য যখন প্রস্তুতিটা নিই, সেটা এনসিইআরটি বেস্ট প্রস্তুতি থাকে এবং বেশিরভাগটাই আমরা এনসিইআরটি ওরিয়েন্টেড পড়াশুনো করি। যদি আমি ইঞ্জিনিয়ারিং জেই মেনের ইন অ্যাডিশন টু দ্যাট আইআইটি জয়েন্ট এন্ট্রান্সে অ্যাপিয়ার করি, সেক্ষেত্রে আমাকে তার প্রস্তুতি আলাদাভাবে নিতে হবে। তো ওয়েস্ট বেঙ্গল জয়েন্ট এন্ট্রান্স এক্সামিনেশনের সিলেবাসটা যদি আমরা ভালো করে মন দিয়ে পড়ে দেখি কেমিস্ট্রির, তাহলে অনেকগুলো জায়গাতে দেখব ইন অ্যাডিশন টু নিট বা জেই মেনের যে প্রস্তুতিটা আমরা এনসিইআরটি বেস্ট নিয়ে থাকি, তার বাইরেও কিন্তু আমাদের বিভিন্ন চ্যাপ্টারে বিভিন্ন জায়গায় বেরোতে হবে। এবং সেরকমই আমি 2-1টা টপিকের কথা বলছি এবং আমি পরীক্ষার্থীদের বলবো ভালো করে সিলেবাসটা নিয়ে পড়তে বসার, এবং যে কটা টপিক আমাদের এনসিইআরটি ইনক্লুড বা কাভার করেনি সেরকম কিছু টপিকের ব্যাপারে আমি কথা আপাতত বলছি। যেমন আমি লিস্ট ওয়াইজ বলছি, ইন ফিজিক্যাল কেমিস্ট্রি আমাদের রেডিও অ্যাক্টিভিটি অ্যান্ড নিউক্লিয়ার কেমিস্ট্রি, প্রিভিয়াসলি ইট ওয়াজ দেয়ার ইন ফর জেই অ্যাডভান্স, বাট last 2-3 years IIT Advance is trying to make it parallel with NCERT. So that's why IIT তেও এবছর কিন্তু রেডিও অ্যাক্টিভিটি ভালো করে ভাবলে নেই। আমরা রেডিও অ্যাক্টিভিটি আইআইটি অ্যাডভান্সে পেতে পারি অ্যাজ অ্যান অ্যাপ্লিকেশন অফ কেমিক্যাল কাইনেটিক্স, ফার্স্ট অর্ডার কাইনেটিক্সের অ্যাপ্লিকেশন হিসেবে। বাট ইন ওয়েস্ট বেঙ্গল জয়েন্ট এন্ট্রান্স দের ইজ এ বিগ চ্যাপ্টার ইন ফিজিক্যাল কেমিস্ট্রি, রেডিও কেমিস্ট্রি অ্যান্ড নিউক্লিয়ার কেমিস্ট্রি। Radioactivity and nuclear chemistry. In physical chemistry, this chapter is not included in NCERT or for JEE Main and NEET. In hydrocarbon part, when we study the chemistry of alkenes, in preparation of in properties of alkenes, alcohol from alkene, in NCERT includes hydroboration, but NCERT does not include oxymercuration, demercuration. Oxymercuration, demercuration. This is one method to prepare alcohol from alkene. In NCERT we have seen that in alcohol chapter they are using hydroboration to make an alcohol from alkene, but they are not discussing this reaction, named reaction we can say. In aldehyde ketone chapter, carboxylic acid, in aldehyde and ketones there are many aldol condensation reactions, but in addition to NCERT study, we must, for West Bengal Joint Entrance, we must have understanding for Parkin reaction or Parkin condensation, benzoin condensation. Generally for NEET or JEE Main, we do not discuss these reactions. For advanced, these are all required, but for JEE Main or NEET, we do not discuss these reactions, but it is required for West Bengal Joint Entrance. Wittig reaction. This Wittig reaction is basically preparation of carbon-carbon double bond from carbonyl compounds. Very important reaction. George Wittig was awarded Nobel Prize in 1979 for this and other chemistry along with H.C. Brown. So, this way there are many named reactions which are there in West Bengal joint entrance, but not there in NCERT. In inorganic chemistry, in the chapter of chemistry of metals, we will see that chemistry of metals, that is in the chapter metallurgy, we do not have for JEE Main manufacture of steel, and alloy steel. There are three methods: Siemens-Martin method, LD method, open hearth method. These are descriptive, but this is there in West Bengal joint entrance manufacture of steel. But generally we do not discuss it for either JEE Main or NEET or even for advanced. So, this is typically exclusive for only West Bengal joint entrance. So, we must take care of these topics, and so let us discuss a few MCQ, one or two MCQ typical based on these ideas, what we do not include in NCERT. So, radioactivity থেকে আমরা একটা প্রশ্ন ডিসকাস করছি। The question is based on stability of atomic nucleus and stability belt. A plot of the number of neutrons against the number of protons of stable nuclei exhibits upward deviation from linearity for atomic number Z is greater than 20. For an unstable nucleus having n by p ratio less than 1, the possible modes of decay is or are. So, this question may be there only in more than one option correct questions. Explain this question, we need to understand what is stability belt. N by p ratio, if it is 1, then it will follow this line, but according to the problem it is said that it deviates from linearity as atomic number goes above Z is equal to 20. So, basically this is the stability belt. Beyond this belt any isotope is not stable. N by p ratio is greater than 1, n by p ratio is less than 1. So, if it has n by p ratio is greater than 1, it will try to make it less. If its n by p ratio is less than 1, it will try to make it more. All isotopes in this belt is stable. This is called stability belt. They are all stable nucleus. Now, four options were there: beta positive emission, beta negative emission, neutron emission, and K electron capture. Neutron emission, K electron capture. Now, if any isotope with atomic number A and mass number B, if it accepts an electron from its K cell, then it will be a new isotope with atomic number A minus 1. That means N by P ratio is increasing, because the isotope has N by P ratio less than 1. So, it will try to make it more. So, that is why it will gain a K electron from its K cell. This is known as K electron capture. It is possible. And another option was there, beta positive and beta negative. Like X is an isotope of any element. If it loses a positron, then it will end at an isotope with atomic number A minus 1. That means again N by P ratio is increasing. So, correct answer to, if N by P ratio is less than 1, it will try to make it more by losing beta positive, that is positron, or by gaining a K electron capture. These are correct. That means very simply, if the stability belt, any isotope in this region will undergo alpha emission, beta minus emission, any isotope in this region will try to make its N by P more by gaining K electron or by losing a beta positive ion. So, this is again more than one correct question maybe asked in more than one option correct, and this is a question but as we are seeing from organic chemistry, and I have said this question based on hydroboration oxidation and oxymercuration demercuration, because we know that hydroboration oxidation is a syn addition, whereas oxymercuration demercuration it follows both syn and anti addition. In this question they are asking the incorrect, we have to choose the incorrect statement, and we have to consider these reaction results 100% yield, and there are 4 options given. I have to choose which are incorrect given. In reaction 1 given alkene, this is cis 2 butene, but these are not hydrogen, these are deuteriums. Alkene, cis water addition is syn addition, so product formed is meso. In this reaction they are saying the product will be formed which will be meso, means optically inactive, and 2 fractions obtained consider only organic compounds. That means we have to consider only the organic products, not the side products. When we will distill out the product mixture, we will get 2 fractions in reaction 1 they are saying, and in options it is given diastereomeric mixtures formed in the reaction 2. They are saying in these reactions we will get a diastereomeric mixture, and in the option 4 they are saying 2 fractions obtained consider only organic compounds. That means in reaction 2 we will get 2 fractions if we distill out the organic products in reaction 2. So these are basically 4 statements are done, and we have to choose which are incorrect. So let us discuss this question on this board elaborately. So this molecule, this is CH3, this is CH3, this is D, this is D. If we perform hydroboration oxidation, B2H6, THF is the solvent, H2O2 in the oxidation step we require in basic medium. We know that this results into syn hydroxylation product. That means the product will be this is D, this is D, this will be OH, this will be H, and there will be another product also, CH3, CH3, OH, H, D, D. So that means what are their relation? They are mirror image of each other. That means 2 products are enantiomers, enantiomeric of each other, and enantiomers have same boiling point. That means we will not get 2 fractions, and neither they are meso compound. That means the first 2 statements regarding reaction 1 were incorrect. Now we are shifting for the second reaction. This is hydroboration oxidation. Now we are considering this reaction. This is oxymercuration demercuration, and the reagent we use generally mercuric acetate in the oxymercuration step. In demercuration step we use sodium borohydride, and here we will get both syn and anti hydroxylated product, hydrated product basically, and the products are, as we get both syn anti, that's why we will get a new chiral center to be generated here. There were 2 chiral centers generated after addition of H2O via hydroboration oxidation, but in this case when we add H2O across carbon-carbon double bond via oxymercuration demercuration, that time we get hydrated product, but in this case only one stereo center is generated, so they are also enantiomeric of each other. That means they are not diastereomer. That's why as they do have same boiling point, again we will get only 1 fractions. That means all the statements done in that previous question were actually incorrect. So correct answer is A, B, C, D. Let us check the statements again before. In option A they are saying reaction 1 gives meso product, but we explain it is not meso, enantiomeric products were there. In option B they are saying 2 fractions obtained, as the products are enantiomer we will get only one fractions because they have same boiling point. In the option C, they are saying diastereotic mixtures formed in the reaction 2, but in the reaction 2 we explained that we had an again enantiomeric product mixture, and as they were enantiomer we will have only one fraction on distillation. That's why A, B, C, D all the statements are incorrect. So only two questions we have discussed, and I expect all my students will do very good in coming West Bengal Joint Entrance Engineering examinations. Best of luck to all of you.